I'm delighted to be invited here to present the various technologies regarding power supply traction system, track, signaling, civil structures used in NCRTC to you people so that we can understand it better. With all your permission, can I start my presentation? Thank you. So, why RRTS? Actually, we are having our metro rail transit, bus rapid transit, and at national level, we are having national railways and airways. However, at regional level, which of the route around 150 kilometer, we are not having that robust transport system. So RRTS is basically semi-high speed rail system which fills the gap between national level and city level. So how it gives the support to the public transport? As of now, if we see from Delhi to Meerut, the overall percentage is 37% which comes to the public transport. Once this Delhi-Meerut RRTS corridor will be functional, the public transport share will increase from 37% to 63%. So it was very much important to place some RRTS system, and to place this kind of system, National Capital Region Transport Corporation was formed, and in December 2016, DPR for Delhi-Meerut corridor was approved. However, in March 2019, the project was approved, and since then, we are working day and night to complete our Delhi-Meerut RRTS corridor. As of now, we are having two phases, and in first phase, we are having 3 corridors. On first corridor, Delhi-Meerut, we are working as of now. On second corridor, which is Delhi-Alwar, this is under approval, and Delhi-Panipat, DPR is prepared, and this has been submitted for approval. Now come to the Delhi-Meerut corridor, which is basically divided into 4 stages, and we are ready with the first stage, which we call as priority section. This priority section is basically 17 kilometer elevated section, wherein overall 5 stations are coming. So this priority section is ready and got sanction from Commissioner from Metro Rail Safety. Now come what RRTS can offer to its passengers, its user. So first, if you see, we are having design speed of 180 kmph, and our train can run on the operation speed of 160 kmph. So the total length of Delhi-Meerut corridors is about 82 kilometer, and average speed of our RRTS is coming around 100 kmph. So with that speed, we can complete the whole corridor within 1 hour, even less than 1 hour. Second, what we can offer to our passenger is the frequency of 10 minutes. So every 5 to 10 minutes, you can get one train, so you need not to wait for the train. It's just like metro. Anytime you can go to the station and you'll get the train at the most in 9 minutes. Now come to interoperable facility. Interoperable means if you are sitting from Meerut and you want to go to airport, you need not to change the train. The train will change the corridor. So in case of metro, if you compare, if you want to go to place A to B, and you have to change the train in between. But in case of RRTS, the trains are interoperable. They can go from one corridor to another corridor. Like from Meerut to Delhi and Delhi to Alwar, you can go in one train only. Then we have provided universal access for all type of passengers, women, differently abled passengers, elderly people. We are providing the access to our stations as well as to the trains also. Then high capacity, comfortable journey, and seats are like airlines. This is weatherproof because it is having dedicated system, dedicated transit system, so we need not to worry about the weather. We will be on time. Then commuter friendly information system. What does it mean? We can have QR code on our mobile. We can have mobile application through which we can book our ticket. We can go from one place to another. Now come to the power supply and traction system, which we are using in this kind of transport system, which is having higher speed as compared to metro. So switch gears, as we have to make the system very much reliable and maintenance free, so we have used gas insulated switch gears in it. Earthing system, this is very much safety concern. So we have used ground enhancement material for this, along with the copper cladded rods and exothermic joints. So we are getting, as per standards, if we are getting less than 1 ohm for the overall grid earth resistance, we are getting 0.5, 0.3 against the requirement of 1. So that much of effective earthing we are having. As per CA guideline 2010, voltage and current harmonics to be kept in the limit. However, in the metro systems, there is much imbalancing because of the regenerative and two-phase consumption to the metro system. So we are having active power filter in our substations to keep the voltage, current, and power factor imbalance within the limits. After that, we are using flexible overhead current system, catenary system, which is designed for 180 kmph. For 180 kmph, we have kept two types of criteria. One is size of our conductor and catenary wire. So that is, we have kept 150 and 120. And another one is the tension between wires. So that we have kept 150 kilonewton. Normally we see 1200 in other systems. So we kept 1500 kilonewton in our system to have the better current collection. Modular cantilevers and spring type ATD we have used. Rigid overhead catenary systems designed for 180 kmph, though it is designed for the higher speeds, but it has been used for our system. Apart from this, we are using sustainable. See, energy is the very high share in the operational cost. So what we are doing, we are keeping solar power panel in all our rooftops. We are going for the blending of the power. Like with conventional power, we are doing the renewable energy memorandums with other companies which are working on RESCO model. Other than that, we are using solar tube lights in our RSS and depot buildings. So in daytime, there is no need to run the conventional lights. So if we cover all these system technologies in civil structure, what we are doing, we are having the civil structure which is capable of supporting the track and the rolling stock, which is designed for 180 kmph, as well as the high tension of the overhead traction system. Similarly, for track structure, we are having precast track slabs and proper fastening which are suitable for 180 kmph design speed. Then, as I earlier you mentioned, flexible and rigid overhead catenary, which is designed for 180 kmph. Signaling, yes, we are using first time in India ETCS level 2 on LTE. This we are using first time. Rolling stock, of course, this is new to India, and I'm glad to share that this complete rolling stock we have designed in India and we have manufactured in Savli, Gujarat. And then integration with other services like multimodal integration, which we are doing at our Sarai Kale Khan station, Ghaziabad station, Sahibabad stations, everywhere where we can do the multimodal integration with the other metro and other transport services. And one more thing I want to mention here, in Meerut city, we are doing the RRTS services and MRTS services on single track. So MRTS system is subsumed in the RRTS system. Other than that, for operations to make this sustainable, what we have done, we have given the O&M contract to outsource company, which is DB RRTS Operational India Private Limited, for 12 years. And for maintenance of the rolling stock, we have given the maintenance contract to the OEM, which is Alstom. Other than that, during execution, what technologies we have used? For planning of our project, we have used Primavera and Speed. Speed software is our in-house software. Then common data environment, building information modeling, virtual reality. This we have used for our drawing, our approvals, our class detections. For these purposes, we have used these tools. Videography, for the day-to-day progress of the system, we have used this CCTV, PTZ cameras and all. Geospatial information system. This we have used for land value capture and land survey systems. Then track alignment and simulation. For this, we have used Open Rail design software and Open Track simulation software, through which basically we are very accurate in our track alignment. Similarly, we are using continuously operating reference stations, which is called CORS, which is real-time data which is coming to your centralized system, and it gives you the accuracy of your alignment. Now, with all these technologies, see, visual is more than speaking, so I'll take you to one small video through which you can understand we are ready for our priority section to be placed in service for public. thank you everyone for listening me. And I just want to make one statement here that from 2019, from March 2019, we got the approval. And in June 2019, we have started our work. And within this short span of 4 years, the work is going on the complete corridor of 82 kilometer. And we are ready. Out of that, we are ready with priority section of 17 kilometer to serve you. Thank you. Thank you very much.